Hi, my name is Milena Pukalo and I am part of 11A, and today I'm going to be presenting and helping you understand vectors and precalc. Vectors is a really important subject, and we're going to take an in-depth look at some of the world's most key principles to understanding an advanced introduction to calculus, precalc, vectors. So let's get started. But what is a vector, you may ask? Because what if you never heard of it? So a vector is a magnitude or a distance, that's what magnitude means, math application that contains the magnitude and direction, as well as the degrees to tell you where it goes. So as you can see on this image right down here, we have an example of image A, which shows vector 1, u, and vector 2, v. And when you add those two, as a result, you get vector C on image A. Same thing with image B, we have one vector and second vector, but because it's upside down, we'll subtract it. But we'll just be looking at adding the vectors today. So how can we solve vectors, you might ask? You can solve vectors by using your calculator, which I do not have with me. It is right here. Or you can also use Desmos or MATHWAY to help you along with those. And those are really helpful. I'll talk about those later. So I'm using Google Slides to present this little lesson, Zoom in order to record everything and get it in a video, iMovie to edit a little bit if I need to edit, Spotify to play some background music, Desmos, which I already spoke about, MATHWAY, and I will be using YouTube as a platform to upload it. All of these devices and things I'm using are available to your service online to download. Please use my links below if you want to download them. And iMovie is only allowed on iPhones and like iPads and stuff. So yeah, if you have an Android, that's too bad. I don't know what to tell you. YouTube is accessible to any platform as long as you are over the age of 13. So I hope you guys have fun getting those platforms and using it to your most outcome. So why is vectors important in the world? When we are given a life and death situation, such as if you were put on the Titanic and you were about to die, you need to get off the boat, right? And you need to survive. Well, how can you do that unless you get to the exit? But you might not know the way to get to the exit. You have two distances because that's where you went to get to the pizza on the cruise and that's where you got ice cream. But you don't actually have a way to get to the end position, which is your exit point. And you would die if you couldn't calculate the vector yourself. So you really have to calculate the vectors. And when you do that, you can get off the boat. And also if you're building a house or something and you need to find out the degrees and magnitude, you can simply do this once you learn how to do vectors. So how can we actually solve vectors, you may be asking right now? Well, if we're given two distances, vector 1 and vector 2, we can find the red line, which is vector 3. So we need to know what cosine and sine mean. Cosine is a function and is horizontal, while sine is vertical. So today we're going to use the component method, and I'll teach you how to do this. So when we're looking at vector 1, which is the bottom vector, 20 degrees and 6 meters from the starting point we are using, which is kind of the x-axis, we're going to want to use the component method, which will do cosine plus cosine and sine plus sine because it's very important. So using vector 1, we can do 10 times cosine 85, which is the magnitude times the degree, adding vector 2 to that. And then we're going to want to add in the second vector because we have a sine and cosine component. So cosine is that's sine. So once we add those, we need to figure out actually what the heck can we do to that. So if we have 10 star cosine 85 and we do all the math for that, we get 6.5 meters and 12.01 meters. So if we want to find that red V3, vector 3, the resultant vector, we're going to want to find the magnitude. You can find the magnitude by taking the square root of the vector 1 sine component and the cosine component, and then finding the square root of it by starring it and multiplying it. So when we do that and we take the square root of 6.5 times 12.01, and then we root it, we get 13.65 meters. So now we know vector 1, vector 2, we have the resultant vector length, so we know how long it is. Now we need to find how far is it from the center, because it's like right there. And you can find it by doing the tangent inverse of y over x, or cosine over sine. So when we are doing that, we get 12.01 over 6.5. which equals to 61 degrees. Now, this leaves us with a really important factor. How can you actually say it's a resultant vector, you know? Because you can just do all this math for no reason, but when we are given our resultant vector, we actually need to phrase it correctly. So we got 13.65 meters for that problem example and 61 degrees. But because we started from this region going up, we're 61 degrees northeast of our origin, or we could say 29 degrees from north because, you know, math. But once we have our resultant vector, you can just say 13.65 meters, 61 degrees northeast of our origin, and that is how you can find simply a resultant vector. So one really important thing I found is you can check with different apps or services, and I'd love to put you on to MATHWAY. MATHWAY is a really important platform that encourages you to do math and not cheat and like do your own math and check it by incorporating different math processes. And it's really important, and you should use my referral link in the bio for MATHWAY. So oh yeah, here's the MATHWAY screen. I forgot to show it. So you can just check it by like plugging it in. Same thing as a calculator, but it's like a lot more helpful and you can like visualize it and stuff. Super great, super great. I'm not sponsored. So Tsang, oh my god, that's no. Thank you so much for watching. I put Tsang, no. I hope you learned something with the aid of this tutorial, and you can use the subscription services I told you about to improve your day in your math class and your grade. And I really hope you enjoyed this tutorial. Like or dislike, I don't really care. So yeah, thanks for watching.